Here we're going to look at equations involving hyperbolic functions. We'll take a very simple one to start with. Solve cos x equals 2, giving the answer as a logarithm. Well, it looks as though this is very simple. We can just write that x equals r cos 2, and if we remember the logarithmic form, that is log 2 plus root 2 squared minus 1, which is log 2 plus root 3. The only problem there is that r cos is a function which only gives one answer. And if we're trying to solve cos x equals 2, here's cos x equals 2, there are two answers, plus or minus a. So I should really write, instead of x equals r cos 2, I should be writing plus or minus r cos 2, plus or minus, plus or minus. So that is somewhere where we have to be just a little bit careful. On the other hand, if we solve cos x equals 2, using the exponential method, we get a half e to the x plus e to the minus x equals 2. Multiplying both sides by 2 will give us e to the x plus e to the minus x equals 4. Multiply by e to the x, subtract 4e to the x from both sides, and we now have a quadratic equation in e to the x. Quadratic equation e to the x is minus b plus or minus square root b squared, which is 4 squared, minus 4ac over 2a, and that simplifies to 2 plus or minus root 3. And so x, they're both positive, those roots, x is log 2 plus root 3, or log 2 minus root 3. Now we seem to have a disagreement. We have plus log 2 plus root 3, or minus log 2 plus root 3. We have log 2 plus root 3, that's fine. But instead of minus log 2 plus root 3, we've got log 2 minus 3. So let's see if we can sort that out. Minus log of 2 plus root 3 is equal to log 2 plus root 3 to the minus 1, which is log 1 over 2 plus root 3 times 2 minus root 3 over 2 minus root 3. That's all within the logarithm. Working that out, 2 minus root 3 on the top, and on the bottom we have 2 squared is 4 minus root 3 squared, and that therefore is log 2 minus root 3. So we've shown that minus log 2 plus root 3 is equal to log 2 minus root 3. In other words, the second root here is the same as the second root there. So no problem after all. The next equation has a very familiar look to it. If this was a trig equation, 6 sine x minus 2 cos x equals 7, you would use r cos x plus alpha. You could use r cos x plus alpha using the identities that we have met, but in this case it's easier if we use exponential technique. So let's rewrite this in terms of e to the x. I get 6 times a half e to the x minus e to the minus x minus 2 times a half e to the x plus e to the minus x equals 7. This gives me 3e to the x in the first bracket minus e to the x in the second. So that's 2e to the x minus 3e to the x in the first bracket, 3e to the minus x minus e to the minus x in the next bracket. So that gives me minus 4e to the minus x equals 7. If we now multiply by e to the x and subtract 7e to the x from each side, we have a quadratic equation. Always nice to see if they factorize. If it does, it's got to be 2e to the x and e to the x. I want to have minus 7, and that will do it for me. And so e to the x is minus a half. Well, that's not possible. Not if we're thinking of x as a real number, anyway. Or e to the x equals 4. And therefore, the solution to this equation is x equals the natural log of 4. We have another equation which looks fairly familiar. If it was cos 2x plus 5 sine x minus 4 equals 0, you would probably do that with a trig formula. We could try using exponentials. We would have e to the 2x, e to the minus 2x, e to the x, e to the minus x, constant term, multiply through by e to the minus 2x, and you would have e to the 4x, e to the 3x, e to the 2x, e to the x, and a constant. You would have a fourth degree equation in e to the x, which might not be very nice. So in this case, it is preferable to use the trig type approach. Well, cos 2x is 1 minus 2 sine squared x, but remembering Osborne's rule, sine squared, we changed the sign. So instead of 1 minus 2 sine squared, we get 1 plus 2 sine squared, plus 5 sine x. I've lost an n, minus 4 equals 0. Simplifying that, we get 2 sine squared x plus 5 sine x minus 3 is equal to 0. Will that factorize? Well, if it will, it's got to be 2 sine x and sine x. I want 5, so I've got to have the 3 there. I want plus 5. So I now, yes, that works. I get that sine x is equal to a half or minus 3. So remembering with sine x, if you think of the graph of sine x, the range is any real number. So this is going to give us two solutions. We get that x is equal to r sine a half or r sine minus 3. For giving the answer as a logarithm, we need x is equal to log a half plus root a half squared plus 1, or log minus 3 plus root minus 3 squared plus 1, which gives us, simplifying that, log this one, you get root 5, you get a 1 over 4 plus 1 is 5 over 4, that's root 5 over 2, so that's 1 plus root 5, all divided by 2, or log under the square root sign, we've got 10, so that is root 10 minus 3. As I said, this is a better technique than using the e to the x technique. Here we are given that sin x is 5/12 and asked to find the exact values of cos x and cos 2x. You can't draw a triangle. It's not that sort of thing. Sin x, 5/12. If x was acute, we could draw a triangle. So we must use our trig formulae. Cos x. Well, I need a trig formula there. Remember that cos squared x, well, it would be cos squared x plus sine squared x is 1. Osborne rule tells us that sine squared gives minus. So cos squared minus sine squared x is 1. Cos squared plus sine squared is 1. Cos squared minus sine squared is 1. And therefore, cos squared x is 1 plus sine squared x, which is 1 plus sine squared is 25/144, which is 169/144. Square rooting, cos x is equal to plus or minus 13/12. And I expect most of you would have left out the plus or minus, and you would have fluked the right answer. Because cos x, think of the graph, cos x is always greater than or equal to 1. It's never negative. So cos x is greater than or equal to 1 for any value of x. Therefore, in this particular case, cos x is equal to plus 13/12. Okay, that's one part of the question done. Let's look at the second part, cos 2x. Cos 2x, I can use trig formulae, or the equivalent in hyperbolic functions. I remember that cos 2x is 1 plus 2 sine squared. Why? Because I know that cos 2x is 1 minus 2 sine squared, and Osborne's rule will turn that into a plus for me. So that is going to be 1 plus 2 times sine squared is 25/144. That is 194/144. And if we cancel a 2, we get cos 2x is 97/72.